Okay, folks. So if you've never seen this notation, we're going to do this. This is I is starting at 1. So I'm going to go 3 times 1 plus 1 plus 3 times 2 plus 1 plus 3 times 3 plus 1 plus 3 times 4 plus 1 plus 3 times 5 plus 1. The bottom number tells me where to start. The top number tells me where to end. Sorry, I made an assumption there. And so you could crank all that out and you would end up with a sum. And so this here is, or let's do this one. So summation I equals 1 to 4 of I squared is going to be 1 squared plus 2 squared plus 3 squared plus 4 squared. Make sense? Yeah. Now, notice we're not doing the limit yet. We're just trying to manage this for right now. Does that help with the summation? So when I equals 1, this is x of 1, whatever that value is. So I'm now going to replace x of I with what x of I is equal to. X of I is 3 over n.
Why did you put an I next? I understand that you got the inside there from the original function, but why did you put an I next to all of this?
It's not next to it, it's a subscript.
A subscript. Why do you add a subscript?
Because up here. Each one's different as we go through. I'm going to go ahead and cube everything. I also need to mention this. So I can like factor a constant out if I need to. That's distributive property, because we're just adding up pieces, right? Another rule. So if need be, I can break things into 2 separate pieces, 2 separate summations. Whether I'm adding or subtracting, I can break that down like that. Now, I'm going to summarize all this up in just a few minutes, but before I get going, what I'm going to do is I'm actually going to break these into 2 separate pieces here. Please note that the 27 over n cubed, 27 over n cubed is a constant relative to the summation. There's no function of I in here anywhere. Don't blink.
That's why we got YouTube.
I'm going to give you a few minutes to piece that together.
Isn't it 54?
Which?
48?
3 times 18.
Isn't
Oh,
it
that's not right.
54?
That should be 54.
Yeah.
Oh, is that what you were saying? I'm sorry, yes. I'm old level. So I distributed this in, and then I pulled out the constants relative to the summations. I want to make sure we're all squared away. Any questions so far? I know, it's still kind of like what's happening. Now I know this, right? Now, this becomes a 4, right? Because I square it. Actually, half of 54 is 27. Yeah. Now, that looks kind of weird. I could FOIL this out. I'm not going to. But what is the degree of the polynomial in here after I do FOIL it out? You see it's n to the 4th power, and I got n to the 4th power down here. And what's the degree here? 2 over 2. You remember that rule that says that when we do a limit off to infinity, and the degree in the top is the same as the degree in the bottom, the lead coefficients take over? So if I do
Oh, wow.
notice I have n to the 4th over n to the 4th, and what's going to take over the lead coefficients? What do we get?
27 over 4?
Negative 27 over 4, right?
Yeah.
And if I had Gus do this the fast way, he would get the same thing. Okay. Let's start from the beginning. Some idiot actually defined the area under this curve. From 0 to 3. Sounds harmless enough. So what we do is we define our x of I. We're actually going to be building this from the inside out. So our x of I is here. Our delta x we got from here. we're going to keep it generic as n, and then eventually we'll throw that n off to infinity. That'll be the last thing we do. X of I follows this formula. A is 0, so it's gone. Delta x is there, and then I. So we did f of x of I right here. Delta x is there. We changed our x of i's into what we've defined it as, here and here. Then I broke it down so that we could kind of isolate these elements. After we did that, I replaced that summation with this here, and this one with this here. Did a little bit of algebra, then took the limit. We end up with all that. I'm going to give you guys a couple minutes. Try to talk someone through this. Piece it all together.